Hello class, in this video today, you are going to learn about Content Standard 6.6 Standard Solution atau in bahasa Melayu, larutan piawai. Learning standards that you are going to learn, meaning of standard solution, maksud larutan piawai, describe the preparation of standard solution, iaitu kamu harus ceritakan ataupun memahami penyediaan larutan piawai through activity from a solid substance and through dilution of aqueous solution. Bagaimana untuk sediakan larutan piawai daripada bahan dalam bentuk pepejal ataupun daripada pencairan larutan aqueous. Learning standard number 3, you are going to learn how to solve numerical problems involving preparation of standard solution and dilution. Macam biasa, subtopik ini akan mengajar kamu tentang masalah numerical, pengiraan yang melibatkan penyediaan larutan piawai dan juga melalui kaedah pencairan untuk menyediakan larutan piawai. Jadi, apa itu larutan piawai? What is the meaning of standard solution? Let us go to your textbook. This one is in page 162. Let us look at the photograph 6.2 over here. You are given one barcode over here, one QR code. You will be given this one in your Google Classroom. I will attach it to you. Okay? The question here in your textbook, have you ever seen the syrup dispenser? Kalau tidak pernah tengok, tidak apa. I already attached in your Google Classroom and you can go and check it out. What is syrup dispenser? Did you know that the dispenser is filled with a standard solution of sugar so that the machine can dispense sugar at an amount requested by customer? Okay, macam faham sudah kan? Di mana boleh jumpa ni? GT ada. Okay, Tea Life ada. And then Mock Cafe ada. All of these syrup dispenser telah disediakan mengikut satu larutan yang piawai. Apa yang piawai? Gula. Mengikut customer punya request. So you go and check it out, the video that I prepared for you, that I scanned for you already. Okay? So, apalah maksud standard solution? Most chemical reactions involve reactants in aqueous solution. Kan, dalam amal kita, memang pun kebanyakan tindak balas kimia melibatkan larutan aqueous. Acid kah, base kah, alkali kah, kan? Semua melibatkan larutan aqueous kebanyakan, okay? Most of it. In that case, the preparation of aqueous solution with specific concentration is very important. Siapa yang mau menyediakan asid yang berkepekatan 1.0 mol per cubic decimeter? Siapa yang boleh menyediakan HNO3 nitric acid dengan kepekatan ini atau tukar pergi 2.0 atau tukar pergi 3.0 and so on. Okay, so all of that are prepared by the lab assistant actually, okay? But after you learn the subtopic standard solution, you are going to prepare that solution on your own. Kamu mesti faham macam mana mesediakan larutan aqueous mengikut kepekatan yang tertentu. In the previous subtopic 6.5, you already learned about how to count the concentration, how to count the molarity. Itu semua kamu sudah faham. So, di dalam subtopik ini, kamu akan tengok macam mana sediakan larutan ikut kepekatan yang sudah ditetapkan. Okay. So, apa maksud dia? Standard solution itu apa? It's a solution with known concentration. Dengan kepekatan yang diketahui. Itulah maksud standard solution. In the preparation of standard solution, mass of solute and volume of distilled water are two parameters that have to be measured accurately. Apa parameter yang mesti diukur dengan baik, dengan tepat adalah distilled water, air suling, punya isi padu dan juga jisim pelarut. Jisim pelarut. Okay, let us go to the activity 6.7 here. Tajuk ini adalah preparation of a standard solution from a solid. You remember the DSKP just now, it showed you that in this subtopic, you should learn about the meaning of standard solution. Okay, this one, check. Iaitu, standard solution is solution with known concentration. Yang diketahui. 6.6.2, describe the preparation. Kamu harus faham macam mana untuk sediakan larutan itu melalui dua aktiviti. Satu daripada solid substance. So that's what you are going to learn in your textbook. Preparation of standard solution from a solid dulu. From a solid, daripada pepejal dulu. Okay, so let us look at this activity 6.7. Aim tujuannya is to prepare 250 cubic centimeter of standard solution of 1.0 mol per cubic decimeter sodium carbonate. Ini adalah sodium carbonate. This is sodium carbonate dalam bentuk pepejal in solid form. Okay, so from this solid carbonate, what you are required adalah kamu harus sediakan larutan piawai sodium carbonate itu dengan menggunakan pepejal tadi. Gunakan ini, tapi tukarkan dia kepada larutan aqueous. So, macam mana itu? What you will need, materials, distilled water, air suling, dan juga solid sodium carbonate. That's all. You need this and also water. Itu saja. Apparatus. You need to use electronic balance. Tahu kan electronic balance? Okay, alat pengukur elektronik. Filter funnel, 250 cubic centimeter volumetric flask. If you forgot what is volumetric flask, this is volumetric flask. Okay, kelalang volumetri. Di bawah dia, dasar dia rata. Okay, and then you will need, okay, filter funnel. If you forgot, this is filter funnel. Filter funnel adalah corong turas. And then you will need dropper. Dropper penitis. Penitis ini. This is dropper. And then you will need wash bottle. What is wash bottle? Wash bottle is like this one. Okay? Wash bottle untuk isi distilled water. 250 cubic centimeter of beaker and glass rod. Beaker and also glass rod to stir. Why I need to explain this one by one? Because after this, you are going to do this exercise in Cikgu Azmi's book. Okay? You will need to do all the procedures. There are 7 marks for the procedures. The thing that I'm going to tell you, to explain to you right now, this one, all of these consists of 7 marks. Jadi, berbahagialah kepada sesiapa yang boleh memahami langkah kerja ini. Okay. First, determine the mass of sodium carbonate needed using the formula N equal to mv over 1000. This one you understand already. Let me show you in Cikgu Azmi's book. Okay, langkah 1. Dalam buku Cikgu Azmi, dia bukan guna sodium carbonate. Dia guna sodium hydroxide. Sama jugalah. Preparation of 250 cubic centimeter of 0.1 mol per cubic decimeter. Kalau dalam buku teks mau sodium carbonate 1.0. Dia punya kepekatan 250. Dia punya volume. Cikgu Azmi's book pakai bahan kimia yang lain, kepekatan lain, tapi isi padu yang sama. Sama juga materials what you need, solid sodium hydroxide. Solid. Sebab kita sekarang belajar macam mana mau sediakan larutan piawai daripada solid. And also distilled water. So apparatus, electronic, sama jugalah. Okay, electronic balance, beaker, volumetric flask, glass rod. This is the step number 1. Mesti mau pandai calculate the mass of sodium hydroxide by using this formula. That's the first thing because kamu punya bahan sekarang dalam bentuk pepejal. Okay, so we need to find the mass. Now, how to find the mass dulu? We use this N sama dengan MV. You still remember in our previous subtopic, N equal to MV, this one is actually mole. Bilangan mole. Number of mole. So, what you do, you take the M. M besar is molarity. Here is the molarity. Put here. Times darab dengan dia punya isi padu. Okay, this is the volume needed. Kedua-dua ini diberi. Kedua-dua ini sudah diberitahu. So you just need to put in the formula and then bahagi 1000. Why you need to bahagi 1000? Because this is in cubic centimeter, bukan desimeter padu. Kan? You need to change it to cubic decimeter. Because ini formula mesti dalam DM padu. Faham kan? I explained in the previous subtopic already. So you got 0.025 mole. How to find the mass daripada mole? Remember that we already learned about the first number of mole formula. If I'm not mistaken, this one is the second one, not the first one. Sorry. Okay, mole is equal to mass over molar mass. This one we have learned this in chapter 3 already. So what is the mole? Mole is the one that you found from this formula. So you just put 0.025 here. What is the mass? That is the thing that you want to find. Mass of sodium hydroxide, Nina. Bahagi dengan molar mass. Molar mass, you understand already kan? Na berapa? 23 plus oxygen 16 plus H1. Darab. Dapatlah X. Iaitu 1.0 gram. So that's how you find the mass for the solid substance. Ingat, kamu punya bahan sekarang ni adalah dalam bentuk pepejal. So you need to find what is the mass needed untuk dicairkan dia, untuk disediakan. Okay, langkah 2. Okay, let's go to langkah 2. Okay, I will use your textbook. Sama juga. Okay, class. So now you understand that you need to find the mass by using N sama dengan MV. So what you do, M is equal to mana? 1.0. Because that's the molarity yang dia mau. Volume is equal to 250. So this is what you should do. First thing first. After that, okay, you got the mass already. So you weigh the mass. Timbang lah. Weigh the mass calculated using electronic balance. Add 100 cubic of distilled water to the solid sodium carbonate in a beaker. Selepas kamu timbang, then you put inside the beaker like this. Okay? This is the solid sodium carbonate yang kamu sudah kira. Let's say we need to use 1.0 gram. So add 100 cubic decimeter of water later. And then stir the mixture with the glass rod until all the solid sodium carbonate is completely dissolved in distilled water. Next is you need to stir. Okay, tadi kita sudah letak 100 cubic decimeter of water. So now you need to stir sampai semua dissolve. Larut sampai semua larutan itu, pepejal itu larut. After that, transfer the sodium carbonate solution into 250 cubic volumetric flask via a filter funnel. Okay, volumetric flask ni, if it's in the lab, dia ada macam-macam size. Okay, ada yang 250, ada yang 100, ada yang 500, ada yang 1000. So depending on what is the volume required, you use that size lah. So in this experiment, you need to tell, mesti membagi tahu, volumetric flask yang size kamu guna adalah 250 cubic centimeter. Kenapa? Because that's what the soalan want you to prepare. 250 cubic centimeter padu of standard solution. Okay? Okay, using a filter funnel. Why use a filter funnel? Supaya tidak tumpah lah bahkan. Okay, tuang ke dalam. Okay, step number 6. Rinse the beaker with distilled water. Make sure all the remaining solution is transferred into the volumetric flask. That's what you do next. Selepas kamu tuangkan yang tadi ini 100 cubic decimeter kan, tuang dalam volumetric flask, and what you do next is use the distilled water. Pastikan semua sodium carbonate ni betul-betul sudah masuk ke dalam. Okay, rinse dia, bilaskan dia. And then rinse the filter funnel with a little distilled water. All the remaining solution is transferred into the volumetric flask. That's what you do. You need to rinse. Pastikan tiada yang tertinggal di atas corong turas. Mesti tepat. Remove the filter funnel. Okay, remove. Keluarkan corong turas. Add distilled water until it approaches the calibration mark on the volumetric flask. Okay. Apa yang kamu buat after that is you need to remove this filter funnel. And then you need to fill in water. What is meniscus level? Meniscus level ni adalah begini. Look at this picture over here. You know that kita punya air ni, when you fill in any shape of glasses lah, dia tidak akan rata begini tau. You still remember meniscus level? Air tu sebenarnya begini dia punya level. So what you do is you need to isi air suling ke dalam volumetric flask until it reach the meniscus level. Di sini, di hujung. Hujung itu U, sini. Bukan ikut yang di bawah. That is meniscus level of solution. And that's what you should do. Tuang sampai meniscus level. Sampai calibration mark. Apa itu calibration mark? Tanda senggatan. Dalam bahasa Melayu, senggatan. Apa itu tanda senggatan? Dia akan ada macam tanda di sini. Tanda di sinilah 250 cubic centimeter isi dia. That's calibration mark. Ada tanda. It's not very obvious because this one is kaca, right? It's not very obvious. Dia bukannya hitam kah, merah kah? No, but memang boleh nampak that calibration mark. So tambah air sampai calibration mark. Using a dropper, add distilled water slowly until the meniscus level is aligned. Ingat, meniscus level tu adalah level di kiri dan di kanan. This one. Bukan ini ya. Is aligned exactly on the calibration mark of the volumetric flask. Why use a dropper? Kalau tidak use a dropper, kalau kamu pakai distilled water in this wash bottle, nanti terlimpas. Terlimpas, you have to buat balik because tidak tepat sudah. Because what we want to prepare is a standard solution. Mesti tepat. Okay, that's why we use dropper. Close the volumetric flask with a stopper, penutup dia. Shake well by inverting the volumetric flask several times until the solution is homogeneous. Okay. Apa yang kamu buat? After you reach the meniscus level, okay, the calibration mark, tutup. Invert it. Kamu harus kasih terbalik-terbalik dia a few times sampai homogeneous. Apa maksud homogeneous? Dalam satu medium yang sama. Maksudnya dia sudah bercampur dalam satu keadaan yang sama. Tiada lagi ada di atas, ada di bawah, ketumpatan lain. No. Dia memang sudah homogeneous. Okay? So, when you kasih terbalik-terbalik, when you invert it, it's not going to tumpah. Okay? You will experience this after the school open. Okay? You must do this experiment. So, tutup, invert it. Terbalik-terbalik. Okay? Look at this note over here, class. Keep the standard solution of sodium carbonate that you have prepared for activity 6.8. This is how you prepare, and this is your standard solution lah. This is your larutan piawai of sodium carbonate. Same goes to the notes in buku Cikgu Azmi. Sama. Okay? Cuma dia punya nota lebih ringkas lah. You can follow it. Please complete this exercise. Soalan 31. Alright? You need to do the calculation first and then you need to do the procedures. 7 markah, campur di sini calculation sudah 8 markah. And same goes to soalan 32. Okay. Look at this note. You need to keep it. This one. Why you need to keep it? Because we need to use the standard solution in the next activity lagi. Prepare the lab report of this one. You need to prepare and you need to jawab all this. Okay? Jawab dia. Kamu kan ada Google. You can search for the answer first. And then when you do the experiment on your own nanti, you will understand too. Oh, begitu pula. Kenapa beaker and filter funnel mesti kena rinse. Okay, you will understand that. So, prepare a lab report. Look at the instruction in the Google Classroom and you do the lab report. Okay? Okay, now that we have learned how to prepare standard solution from a solid substance, kan? Just now we have learned how to prepare larutan piawai from this pepejal. So now we are going to learn how to prepare standard solution through dilution, pencairan of an aqueous solution. Look at the note here in your textbook, page 164. Preparation of a standard solution by diluting aqueous solution. So, pencairan larutan aqueous untuk sediakan larutan piawai. This is another method of preparing solution of known concentration. Nama dia kaedah pencairan, dilution method. This method involves adding water, tambah air, to a concentrated standard solution or stock solution. Yang kita panggil standard solution, larutan piawai, that is also called stock solution. Okay, why do we need to add water? Because we want to produce more diluted solution. Lebih banyak larutan yang cair. During dilution, water that is added to the aqueous solution will alter the concentration of the solution, but it would not alter the number of mole of solute. Apa maksud ayat ini? Bila kita tambah air, contoh dalam gambar raja A, this is concentrated solution, right? Okay, di dalam dia ada solute. Okay, solute tu apa? Contohnya tadi yang kita sediakan tu natrium carbonate. Okay, contoh. So, this solute mula-mula ada 5. Okay, ini gambaran. Selepas kita tambah air, we add distilled water because we want to dilute this concentrated. Dilute means kita mau cairkan dia. Look at the after. We get dilute solution, but dia punya solute tetap sama, I-E-3-4-U. Itu gambaran dia. I hope you understand. It will alter the concentration. Akan mengganggu, mengubah, alter means mengubah. Ubah dia punya kepekatan, tapi tidak ubah bilangan mol solute. Tidak akan ubah bilangan mol pelarut. Oleh itu, hence, number of moles of solute before dilution is equal to the number of moles of solute after dilution. And therefore, it comes out with this formula. N1 equal to N2. What is N? Just now we already learned N equal to MV. Ini bilangan mole. Kenapa over 1000? Because kita mau dalam decimeter padu. Jadi, if you see dilution, bila kamu nampak topik dilution of a standard solution, remember this formula lah. M1V1 equal to M2V2. This is not physics punya velocity and mass, bukan. This is molarity and volume. Molarity and volume. Before and after adalah sama. Sama, okay? Now, let me explain apa di dalam M1V1, M2V2. M1 is the molarity of aqueous solution, iaitu yang stock, standard, before kena larut. M1, sebelum lah. V1 is the volume of aqueous solution before dilution, sebelum. Yang penting sebelah kiri ni dua-dua sebelum dicairkan. M2, molarity of aqueous solution after dilution. This is the one that we prepare, yang kita mau sediakan. Okay? And V2 is the volume of aqueous solution after the dilution. M is for molarity, V is for volume. 1 is before, 2 is after. Before and after apa? Selepas dan juga sebelum pencairan. Seperti ini, contoh. As an example, you wish to prepare 500 cubic centimeter of 0.1 mole per cubic decimeter copper 2 sulfate solution. Ini yang kamu mau. You want 500. Banyak ba ni? 500? Just now, the experiment activity 6.7, dia dapat sedia 250 saja kan. But in this dilution, cuba kamu tengok. Dia mau 500 cubic centimeter. Kepekatan is 0.1 mole. From the stock, daripada stock, iaitu standard solution, larutan piawai, 2.0 mole per cubic decimeter. Ini yang asal dia. Jadi, kita letak di kiri. Look at this M1. This is the original stock solution punya molarity. So, kita letak sebelah kiri. Apa yang di kanan ni? M2V2 is the one that you want to prepare. So, you wish to prepare. So, this is what you want to prepare. 500 cubic centimeter letak sini. Okay? And then 0.1 letak di sini. That's the molarity. So, what is V1? Look at this. Okay, what you do is you need to kasih pindah this one kan here so that you can find the V1. This is basic maths punya jalan kerja. So you have 25 cubic centimeter. Rupa-rupanya 25 cubic centimeter of stock solution of copper to sulfate need to be diluted using distilled water until 500 cubic centimeter of solution is obtained. Jadi rupa-rupanya kamu mau tambah 25 cubic centimeter padu kepada ini 2.0 supaya kamu dapat 500 cm padu of the solution. Okay, macam mana eksperimen dia tu? Let us go to this activity. 6.8. Look at the note over here. The preparation of standard solution by dilution method. Dengan menggunakan kaedah pencairan ni can be carried out through activity 6.8 using guna apa? Guna sodium carbonate solution yang kamu sudah buat tadi in activity 6.7. That is why dalam 6.7 ada nota jangan buang. Simpan dulu because you need to kasih cair in activity 6.8. So how to dilute it? Let us go through this experiment. The aim is to prepare 100 cubic centimeter of standard solution of 0.2 mol per cubic decimeter sodium carbonate. Material, distilled water and 1.0 mol per cubic decimeter of Na2CO3 from activity 6.7. Tadi kan kita sudah sedia 1.0 punya kepekatan sodium carbonate. Dari mana kita sedia? Dari ini. We use the solid substance of sodium carbonate to prepare 1.0 mol per cubic decimeter of sodium carbonate solution. And then in this activity, what you need to do is kasih cair ini 1.0 pergi jadi 0.2. Dan we want to add water, add sampai we get 100 cubic centimeter. Okay, I hope you understand that. Apparatus, apa radas yang diperlukan? 100 cubic centimeter of volumetric flask. I told you already that volumetric flask, kelalang volumetri ni ada pelbagai size. So depending on the soalan, if the soalan say it wants you to prepare 100 cubic centimeter, pakailah size ini. Kalau dia mau 250, pakailah size 250, begitu. Dropper mesti ada supaya tidak terlimpas kan the calibration mark. Filter funnel, corong turas supaya tidak tumpah. And then pipette is this one wash bottle, pipette filler and 100 cubic centimeter of beaker. So what you do? Cuba kamu tengok the soalan here. Soalan dia based on figure 6.29, plan a procedure to prepare a standard solution by dilution method. Buku teks ini, it requires you to plan on your own. Tetapi, the textbook already gave you the picture. Based on figure 6.29, inilah figure 6.29. What you need to do is, based on this picture, kamu perlu rangka procedure. Tuliskan ayat dia. You need to do the lab report as well for this one. Okay? Rangka dia punya jalan kerja. Okay, as I have told you just now, you need to complete this experiment, the lab report for this activity also. Okay, and as you see, the textbook is not giving you any procedure, but you can use Cikgu Azmi's book in page 154. Look at these two steps. Step number 1, calculation. Step number 2, procedures. Refer to these notes and complete the lab report, this one, in the textbook. And answer the discussion as well. If you have problem, please text me. Now let us look at a few example of numerical problems. Okay, masalah-masalah numerical yang melibatkan pencairan. Example 12. Figure 6.30, this is figure 6.30, shows 75 cubic centimeter of 2.0 mole per cubic decimeter nitric acid that is diluted, yang dicairkan kepada X mole cubic decimeter. Maksudnya daripada 2 ni, dia nanti akan jadi berapa? When 25 cubic centimeter of distilled water is added. So calculate the value of X. What is the new molarity? Okay, remember, if you see dilution, you always use the formula M1V1 equal to M2V2. This is the formula for pencairan, dilution. So before dilution, you have M1 2.0, it's given. And you have V1, it's 75, also given. After dilution, what you have is tiada. You only have this one, V2. Okay? X is the M2, the new molarity that you want to find. So how to find the V2? V2 is the volume of solution. Berapa volume of solution? Sudah diberi tips di sini. Okay, 25 cubic decimeter of distilled water is added to 75 cubic centimeter of the acid. Inilah pencairan dia ni. Inilah air yang ditambah. So this is your V2, 100 cubic decimeter. So by using the formula M1V1 equal to M2V2, these are your M1V1 and this is your V2. Okay, so you just need to learn the basic maths. Remember, if you want to find X, yang sebelah X tu pindahkan supaya dapat X saja that you want to find. Okay, so darah bahagi dapatlah 1.5. 1.5 is the new molarity. See, before is 2.0, after is 1.5. Cair sudah. Okay, so this is dilution. Example 13. Determine the volume of 2.0 mole per cubic decimeter hydrochloric acid needed to be pipetted into a volumetric flask 250 cubic decimeter to produce 0.2 mole per cubic decimeter. Okay, panjang-panjang ayat ni, you just need to determine which one is M1, V1, M2, V2. Okay, M1 is the 2.0 because this is the molarity of the hydrochloric acid yang sebelum. Dia mau kamu cari volume yang mau kasih cair ini. So you want to find the V1. How much of water needed to add to 2.0 mole per cubic decimeter punya acid, so that you can have to produce 0.2 punya molarity, which is lebih cair, the M2, and also 250 cubic centimeter of the volume. Okay, so according to the formula M1V1, M2V2, you just need to put everything into its place. This is M1, V1, M2, V2. Darab, bahagi, dapatlah 25. Rupa-rupanya, you need to add 25 cubic centimeter. Then you can produce 250 cubic centimeter of hydrochloric acid yang lebih cair. Okay, so you will need to complete this activity 6.9, solving calculation problems involving the preparation of standard solution by dilution. Ini dilution, so most of it memang guna M1V1, M2V2. Okay, as long as the soalan mention about dilution, remember to use that formula. And also test yourself 6.6. Okay, that's all for now. Please complete all your work. Thank you for listening attentively.